Hello, AP Chem students, and welcome to topic 7.4, calculating the equilibrium constant. The learning objective for today is 7.4.a, calculate Kc or Kp based on experimental observations of concentrations or pressures at equilibrium. So let's look at it. So once we know how to write the Kc for a reaction, it becomes very easy to calculate the value of Kc. So if you know the concentrations or the partial pressures for a reaction at equilibrium, you can plug those values directly into the K expression that you wrote and determine its value. So as a reminder, when we're writing the K expression, we put products over reactants and we raise them to the powers of their coefficients. So we're just going to look at this by doing a practice problem because that's going to help it make the most sense. So calculate the value of the equilibrium constant Kc for the system shown if 0.1908 moles of CO2, 0.0908 moles of H2, 0.0092 moles of CO, and 0.0092 moles of water vapor were present in a 2-liter reaction vessel at equilibrium. So I am going to go through the answer to this. If you want to try this on your own first, go ahead and pause the video now. Okay, so the first thing that we want to do is to actually calculate the concentrations. So remember with equilibrium that we either use concentration values in molarity or we would use partial pressures. In this case, because we have the moles in liters, we're going to go ahead and divide those out, and you're going to get values of this for each of these species. Now all you have to do once you have your concentration or pressure is you plug into your K expression. And so this is 1 to 1 to 1 to 1. And so we do, again, products over reactants. No exponents here since everything has got a coefficient of 1. And then now all you do is plug these values in. Again, products over reactants, make sure that you do that. Pay attention to your details. If you did have an exponent in your expression, you would need to do that to whatever your value is for concentration here. But again, in this problem, we don't have to worry about that. And so now you plug in your calculator and let it do the work. And so we get an answer of 0.0049. And I want to remind you that K is unitless, all right? It doesn't matter how your units work out when you do the math to find your K. K is unitless. It is an equilibrium position. So it does not actually have a unit associated with it. And that is it. So can you calculate the value of K given equilibrium conditions in either concentration or pressure by plugging into your K expression? That is it. And I will see you soon for our next topic in equilibrium.